Yeah, today we're going to be talking about, DuckDB and dbt, how they can work together, and we'll decipher if the combination of these two tools is all hype, or if this is something that we could use in production and in the real world and under real world use cases. Before we dive into that, I'll just give you a quick intro about who I am. Doug did a great job of introducing me, but my name is Cameron Cyr. I am interested in everything data. I love it, all of it, every facet of it. But I do specialize in data engineering. As you mentioned, I'm a staff data engineer at Breezeway. We build a property management software, almost like an entire operation software, actually, for short-term rental property managers. So it's an interesting tech space to be in. But I do live in the Nashville, Tennessee area currently. I'm a data community leader there. I work with different meetup groups, help organize different conferences there as well. I've been using dbt for around 5 years. So it's since the early days of dbt. I found it to be just like one of the tools that I constantly go back to as something that allows me to optimize my workflows and make things just super quick. I can iterate a lot faster. And for that reason, I decided with with my co-author, Dustin Dorsey, that, hey, like, we should write a book on this thing. There's a book not out there in the world yet. There's great documentation, great videos online to learn the tool. It's not a hard tool to pick up, but some folks just like to read. I'm one of those people. And so we sat down and wrote a book end to end about all the different components of dbt, how they work. It doesn't dive in specifically to how you should model data or how it fits into the data engineering space, but it just gives you an overall high-level view of how does dbt work, why should I use it, and it's pretty much open to anybody, right? You could be a data analyst, data engineer, analytics engineer, what have you. The book is great for that. But enough about me. Let's actually dive into this this presentation. So I am going to make some assumptions here that you're familiar with dbt, somewhat familiar with DuckDB, but let's just do a quick review of both so that we can get off to the races and understand why we might want to use the two together. But the first thing would be what is dbt anyway? So it is the data build tool is what dbt stands for. It is simply a transformation tool, right? Data transformation tool. So it represents the T in the ELT or ETL processes. It enables you to do modular data transformations using SQL historically, and then most recently you can now use Python to run some of those transformations as well, which is great because there are use cases where maybe you need to write 50 lines of SQL to do something that you could do in 1 line in Python, right? And so it's nice to have more than one tool in the tool belt sometimes. And then lastly, dbt gives you an abstraction layer for all of that boilerplate code that you might typically need to write for SQL, DML, DDL, what have you. So that's what dbt is. What is DuckDB anyway? So DuckDB is an in-process or in-memory OLAP database, right? So it brings those, basically you can build columnar data sets directly on your machine or whatever single machine you want to run it on. No need to ship off to a distributed system. It provides ACID transaction guarantees when you're actually writing out to the DuckDB database that you're running locally in process, which is great. It does have other features where you could read directly from, say, Parquet files, Iceberg files, or Iceberg tables, JSON files, CSV, and more. There's other options out there as well. It also has the ability to not only write back to that DuckDB single file database, but you can write back to Parquet and JSON, CSV, Excel, what have you. So there's different options for how you want to write that data out. There's also another feature of DuckDB where you can write directly out to AWS S3. So if you wanted to ship off a Parquet or partition set of Parquet files off to S3, that's something you can do as well. So, DuckDB gives you the ability to run analytics in process, much like you might do with Arrow or pandas or what have you in a data frame syntax, but it brings that SQL syntax to you. And so you don't have to necessarily go learn a different data frame syntax all the time, right? You have a SQL syntax that you can do this stuff with, which is great for analytics, great for data science, but we're going to think about this stuff from the data engineering perspective, right? And why you might want to use DuckDB and the combination of dbt in your data pipelines to do that for you, right? So why might you want to do that? Like, why might you want to run data transformations in memory? Well, simply put, many companies aren't transforming huge amounts of data, right? So like there are quite a significant amount of companies out there that use something like Snowflake or Databricks, where we're running, or Spark, where we're running these distributed systems and we're processing like maybe a few gigabytes of data, which is not vast amounts of data. And so like, what if we just processed that data in memory anyway, right? Like, what if we didn't need to ship it off to a distributed system and we just run it in memory? Well, in the past, it didn't make sense, right? Because high memory machines weren't necessarily readily available or affordable, but they are now. So with the combination of high memory machines that are readily available and pretty affordable and DuckDB, we can now just run these data transformations in memory. And just for example, I just looked this up yesterday just to get an idea of like what it might cost to run an EC2 instance in AWS right now for like a pretty large instance. So I looked up this one memory optimized instance. You get 1.5 terabytes of RAM. You can run this machine for roughly $12 an hour, right? And so that was the on-demand pricing. So you could spin this thing up, run your data pipeline, and then let it go. So you have 1.5 terabytes of RAM at your disposal. So if you're only running a pipeline where you're processing even hundreds of gigabytes of data, like you can do all this in memory. You're not going to run out of memory issues, and pretty cheap for $12 an hour. So where does dbt meet DuckDB? Like, what is this all about anyway? Well, there is a DuckDB dbt adapter, right? And so when we're talking about dbt and we're talking about adapters, specifically what we're talking about there is basically a Python package that allows you to point your queries to a particular database using dbt, right? And so that's where the dbt DuckDB adapter comes in. And so you can just install it as a Python package. It's pretty nice because not only does it install the dbt dependencies that you need, but it also installs the DuckDB dependencies for you as well. So you don't have to separately install DuckDB. Like, you just install this one Python package, and now you have dbt and the DuckDB set up and ready to go. And then immediately you can just start writing your dbt data transformations, and it runs an in-memory database that is dropped after the dbt execution. That might sound weird, but it has its use cases, and we'll talk about its use cases in just a minute. But it is nice for also intermediate transformations, right? Where you don't need to actually persist that for a long amount of time. Like, say you just have this intermediate step where you need to transform a certain column, and then you need to write it out to a final table in a separate step. That's fine, because not only can you have that in-memory database, but when you get to your final step, so you need to write them out to CSV or JSON or Parquet, what have you, that can be done separately. And there's ways to configure the dbt project when using it with DuckDB to be able to do that. And it's extremely fast, like extremely fast. Like, you remove the idea of having a lot of network latency, right? You're not having to send your queries off to a database that is not on your machine, right? So typically the way dbt works is it hooks in with an adapter to a database such as like Snowflake, Databricks, maybe Postgres, Redshift, what have you. And what it's going to do is compile those SQL queries. It needs to send those, that compiled SQL code over the network to your database. Your database will run it. And then whenever results come back, it's going to send you like, not the result of the query, but it'll send you like the outcome of the query, meaning like, was it a success or was there a failure or something, right? So there is some transfer over the network that needs to happen there. But when you're running DuckDB with dbt, it still has to send it off to the database, but the database is right there on the same machine in which you were running dbt, and even within the same environment. So it's fast for that reason. There are many, many other reasons that that DuckDB itself is fast, but like, that's not necessarily the point of this conversation here. We know DuckDB is fast. There's been other talks about it at this conference specifically. All right. So what are some actual like use cases that we could use DuckDB in combination with dbt? Well, the first one is local development. And this is huge for folks that develop with dbt, because typically, again, within a dbt project where you might use Snowflake or Databricks in production, well, you can have isolated environments, but they're a little bit finicky. Sometimes you have to really go out of your way to set them up. Maybe have to do some custom schema work so that developers aren't overlapping their work. But if you're doing local development with dbt and DuckDB together, you're in a completely isolated environment, right? That database is running on your machine. It's very similar to software engineering practices where they might spin up their entire environment locally on their machine. And if they're writing out to a database, it might be like a Postgres instance that runs in a Docker container on their machine, and they're not going to have to worry about conflicts with other developers. That brings that same benefit to us as data engineers that are doing local development. Again, we don't have to worry about developers stepping on each other's toes. You also get a very tight feedback loop, right? You don't have to ship the code off to the database that's on an external machine, send all that over the network, come back, all that, right? Very tight feedback loop because, again, it's all running locally on your machine. And then last but not least, and arguably the most important for this, is that it's low cost and there's not really any cloud compute cost at this point, right? Like, you are running all of that compute on your machine. And so as long as you can fit all that data relatively in memory, and it doesn't even necessarily have to be in memory, like you can work with larger than memory data sets with DuckDB, which is great. But you're not going to have any cloud compute costs, right? Because it's all happening on your laptop or your machine, wherever you're doing your development. All right, use case 2. So we talked about development. Well, can have very similar concepts for running in CI environments or testing environments, right? So same concept, it's completely isolated. You don't have to worry about running your CI environment in like this potentially overlapping production database. Like sometimes folks run their dbt changes in a CI environment that is like a schema within their production database, and it can work, but it also, to me, sounds a little dangerous if you're running that there. You have the potential of messing up your production data. So you're in a completely isolated environment. If anything goes wrong, like, it's fine. You didn't mess up production. You didn't even mess up like maybe your UAT environment or anything, right? Everything's fine. You can also speed up CI runtimes. Again, you're processing all of that data in memory on DuckDB in a lightning fast database, so you can slow down your CI runtimes, which in turn lowers your CI costs, right? One, from the standpoint of your runners, like if you're using GitHub Actions, if you're taking up less time on runners, that's always a good thing for cost. But also your cloud compute costs from whether it be Snowflake, Databricks, what have you, you can lower those costs because you're not having to ship off all these jobs to your cloud SaaS product, right? And then no need to clean up artifacts at the end, right? You don't have to like go drop the CI database that maybe you built out in Snowflake or something. Like once the runner is done, once CI is passed, like everything just goes away. Because again, it's in DuckDB, runs an in-memory database. It's temporary. At the end of the job, it gets dropped. So it's fine. You don't have to worry about any cleanup there. All right, use case 3. And this will be the kind of the last use case that we talk about here, is writing Parquet files to S3, which is pretty sweet when you're thinking about like the abstraction of DuckDB combined with dbt here. But so you can read in this setup here, we could read data from any supported source. So that could be, again, like we talked about earlier, it could be Parquet files, could be JSON files, could be iceberg tables if we needed to use that as the source. All the data is going to get transformed in memory. So again, think about, we have maybe 2 or 3 intermediate steps. We could utilize that DuckDB database to get those very fast results and process all of it in memory. And then we end in a final state where, like, say the very last thing is, well, we don't want that database to go away, or we do want that database to go away, but we don't want the final results of our transformations to disappear into the ether. We actually want to write those out somewhere. Well, DuckDB natively supports via a couple of plugins that you can add, which is this HTTPFS and Parquet extensions, as you can see over on the right-hand side of the configs. This is like a config in the profiles YAML. But you can ship partition Parquet files off to AWS S3. And so, yeah, if we just look quickly at this top image, which is the profiles YAML we have here, it shows that it's the DuckDB adapter. This path is where we're going to store that temporary DuckDB database. This external root config, this s3//DuckDB lake, this is our S3, this is effectively our S3 bucket. And then extensions to write to S3, you need to have these, if you want to write Parquet files S3, you'll use these two extensions. And then finally the settings, this is just where you're adding all of your S3 config, right? So what region is it in, and then giving your access keys and whatnot so that we can actually make that secure connection. That's how we configure it. But like, how do we actually configure a model? Well, that can be done in the config block, or just like anything else in DBT, it can be done in the config block. It can be done in like a schema YAML file, or it can be done at the project level. But this one, I just did at the model file or the model level, and this is what the config block looks like. So we're going to use this materialize. We're going to use materialize as an external table. So this external config here, if you're used to DBT, you might see typically this looks like, it might be a view or incremental or table, what have you. But here we're going to say external because we're going to send it off somewhere else. The format, this is going to be Parquet, right? So this is telling the dbt DuckDB adapter that, hey, we want to write these files out to Parquet. If we just stop there, it's fine. It'll just spit out a single Parquet file for us with our transformation results, which is okay, but there are going to be times where like that's not ideal, right? Just thinking about Parquet and partition data sets, like we probably want to partition it in some way. And so this is where this options object comes in. And you can clearly see we can give a column or set of columns that we want to partition by. Here, I just, in this this table, I have a column with date. It's just a singular date. It's more or less a timestamp that was truncated down to date. We can partition on that. And then this overwrite or ignore, set that to true so that if there are any conflicting Parquet files, we can just overwrite them or move along. All right, so out of the box, we've talked about the things that DuckDB dbt adapter will do for you, but there are actually some plugins as well that come with this adapter that you can add on to extend the functionality of like the base supported functionality. So starting from the top, we have open table formats such as Delta and Iceberg. Currently, those are read-only, but hopefully at some point we'll get to the point where we can see the adapter having functionality to write those tables as well. I believe the Delta one is like on the way and the development is coming along on that one. I haven't heard anything or seen anything about Iceberg yet, but to me, that would be a big win if I could use this process to actually write out Iceberg files or Iceberg tables and manage all the metadata directly through this adapter. That would be amazing. Maybe the use case isn't so complicated though, and we just need to read and write Excel files or read data from Google Sheets. All that's fine too, and that's something that the adapter plugins will support as well. And then lastly, maybe you have a use case to read and write data from a SQL Alchemy database, SQL Alchemy managed database. That's something that's there as well. So that brings me to the final thing is, would I use this in production? Yeah, I think I would. I would use dbt DuckDB in production today, and we are in some cases. The one place that I would like to see the adapter grow, and for full transparency, I'm not the maintainer of this dbt adapter. I'm super excited for the work that has been done to maintain it today and build it out. But one thing I would like to see is the expansion of the open table formats, whether that be Delta or Iceberg. It would be amazing and totally extend the production ready functionality of this adapter. If I could go all the way in memory up until the point of, hey, I want to write my table out to, or I want to write my data out to an Iceberg table, and using this adapter solely for that would be amazing.